Okay, I've swapped out the larger pulley that was here, which was a almost 8-inch, 7 3/4 inch wheel, with a 5 3/4 inch wheel, and that's still a 3 3/4 inch wheel. We'll go ahead and spin this up so you can see what's going on. This is only marginally better than the 8-inch wheel to the 3/75 inch wheel, to the 8-inch wheel to the 3 3/4 inch wheel. This is 2-inch offset between the wheels, whereas the second setup, which is the 8-inch wheel on this side and the 3 3/4 inch wheel on that side, was a much worse input setup because the amperage more than doubled, almost tripled, trying to get it up to the volt rating of the motor. This one, the amps are at 8 amps, but it's still only at about 2,000 RPM, which isn't this motor's run spot. Its run spot's in 2,400 RPM, 2,500 RPM. So another 400 RPM needs to go there, which will require going back to the original ratios. So I'm going to put the 8-inch wheel back here, and I'm going to put the 7-inch wheel back over there, and go back to the original ratios because that seemed to have the best pull. And then what I can probably do instead of dealing with the pulleys is just go to a 220 volt mains instead of the 120 volt mains. So I'll get a transformer that does 2 to 1 and use it inversely so that I can step it up from the 120 to 220. I'll put the 220 into the variac over here, and then the variac will come out and feed the motor, and that'll give me another 100 volts to play with on top of the 120 volts DC. And that's a 220 volt variac anyway. I'm only using it for 120 currently. It's a 220 volt 10 amp variac, a monster. Anyway, let me power it up and I'll show you the amp draw. I'll show you where the VARs kick in, and I'll show you that they, for the input to VARs, this ratio is worse than the original ratio that was initially set up. Okay, so flip on this dual throw relay, which is still open on one end, connected to the mains. I'm going to come over here and we'll go ahead and spin this thing up. Let's see if we can get it at an angle so you can see the amp draw. Alright, that's the input amps down in the bottom left. It's a lot like the DC controller that was shown in that video from Morocco. Trying to keep it at about 5 amp draw to get it up to the mark. 5 to 7. So right around here is where it should start reverse inducing. Bars coming up. And the voltmeter on. Looking at about 310 volts, right? Currently, bars. At those amps, it's about 3 amps. And because the motor's not in its good spot, if I add capacity for the VARs over here, we'll throw in half a UF, right? Ready? Amperage went up a little bit. You heard a little sag on the DC motor, so the RPMs dropped a little bit to account for that. Voltage went up about 10 volts, 15 volts for half UF. Maybe it's going up a little more here. Let's see. Yeah, 15 to 20 volts. So that's off a half UF, right? So then I had the variac set up so that I could increase that and try and bring it back up. So we up the amps a little more. This is the input volts now. It's almost to 100. The motor's rated for 115 VDC at 8 amps. And look at my input amps, right? I'm already at 7.5 amps. Alright, so there I'm at input, 8 amps, 8.5 amps, thereabouts, right? 488 volts, and because we've come up this little bit, the VARs has also come up, and we're looking at about 5.5 amps VARs at 480 volts, 475 volts, AC, at 120 hertz, roughly. Let's look at the RPM, which is another useful calculation or figure to take into account. Drive side RPM is about 2,050 RPM. Like I said, it's rated for 2,400 RPM, which is the target where we'd be more comfortable at and have less amp draw on the input. So that's what that motor's rated at. And then if we check over for the RPM on the volt, we're at 3251, and that's what was allowed by RPM stack. So about 3250 RPM, right? That's the bar. So 5.5 and about 500 volts. And then here, let's make the pretty light go. Ooh. Alright. That's the first time that's happened. I think that filament just blew out. I guess that's what happens when you put 500 volts through a lamp that's only rated for 230 volts. 100 watt lamp. Yeah. So, I mean, input is way higher than it should be, or needs to be, considering. And we're still below the target voltage we want to have on that DC motor when it's running at speed. So we need to go back to the original pulley setup. So, I mean, this shows you practical parameters and measurements of the working system. Which is ideally what we want to see from these tech people, the QEG people. Anyway, that's the 5-inch pulley to the 3-inch pulley. The 5 3/4 inch pulley to the 3 3/4 inch pulley. And we just shut it off by flipping this off, and it will open that relay. Squeak, squeak, squeak. Anyway, there you go.